This is the first video in Unit 8. One thing that I really love about this unit is that it builds on what you already know since elementary school about fractions. You're just adding algebra to it. So today we're going to be looking at adding and subtracting radical equations just like we would fractions. And just what the objective says, we're going to use the concept of fractions to help us with this. So if we wanted to add two fractions together, fractions that had different denominators, we would know that we would need to get a common denominator. And if we have 1/6 plus 3/4, we have a 6 and a 4, we have several choices. We could very simply multiply the two together, right? 6 times 4 is 24, and that would give us a common denominator of 24. Or we could think about it a little bit more and realize that 6 and 4 are both factors of 12. Either way, we could find a common denominator so that we could add the numerators together. So one simple way is to say that 6 times what is 24, that's 4. 4 times 1 is 4. And once again, that's a self-checking thing because you could just divide 24 by 4 and get 6, so you end up with 1/6. 4 times 6 is 24, 6 times 3 is 18. So we end up with 22 over 24. If we did by 12s, we would say 6 times 2 times 1 is that, so 2/12 is 1/6. And then we would say 4 times 3 is 12, 3 times 3 is 9. And we would end up with 11 over 12. Notice that we don't add the denominators, those stay the same. So those look very similar because if you divide the top and bottom by 2 here, you end up with 11/12. Either way, you get the same answer. So that's the basic concept, and that's all we're going to do, only this time we're going to have rational factors. So on this one we see that we have 2 over u times v plus 3 over u. And another way to think of this is that we would have 2 over 2 times 3 plus 3 over 2. All right, so we could see that u times v would be 6, u is 2, and I need to multiply the bottom by 3 to get a common denominator. I can't just multiply the bottom, I also have to multiply the top because I want to change its form but not its value. So we would end up with 2 over the denominator, plus 9 over 6, which would be 11 over 6. So that's the concept behind it, except we want to use u's and v's. So here you can see that if I just multiply this by v over v, then I would get the same denominator. This would be 2 plus 3v over uv, and I'm done. Now here's a situation when you would have two different numbers, like you would have a 6 and a 5. And so really the only way to get the common denominator is to multiply the two together. So that's what I'm going to do. I'm going to multiply the two together. That's my common denominator. And then I come up here and I see that I have x plus 1, but I don't have this other factor, right? And I would know that the 3 stays the same. So I'm going to leave the 3 here and the 5 here because those were already in the original problem. And then I'm just going to look in the denominator and I'm going to see, what do I not have? Well, I have an x plus 1, but I don't have an x minus 2. That goes here, x minus 2. And over here, I have the x minus 2, but not the x plus 1. Now, you can probably see a pattern here. Sometimes they call it the butterfly method, but anytime you multiply the two denominators together, you can do 3 times the other denominator plus 5 times the first denominator, and you end up with the same thing. And they call that the butterfly method, and it works on fractions and it works on rationals the same way. And so the rest is just simplifying the equation. So I have 3x minus 6 plus 5x plus 5. And I'm going to save a little bit of time by not writing the denominator. And I'm going to do 8x minus 1 over. And then I wouldn't even multiply those together, leave it just like that, and you're done. So these are along the same lines, except that what you'll notice is that we've gotten simpler. These are the same denominator. So really, what do you do when you have the same denominator? Well, you just add the numerators together. So combining like terms, I would have 7u minus 4v over 8v. Now, don't do any of this canceling stuff. You'll have students that'll say, oh, these are v's, we can cancel this. No, 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 no. Not with the minus between them in the numerator. When there's a minus there, the deal is off. If it's a multiplication, then you can do that. You can cancel, but because that would be a form of 1. But this is not a form of 1. In fact, you could write it like this: 7u over 8v minus 4v over 8v. And then that would cancel and that would reduce, but not this one. So I just leave it like this, call it good. Over here, same kind of thing, except notice that this is a minus sign. So you're going to treat this one like it's in parentheses. So you would distribute the negative and then add them together. So I have m minus 3n minus m minus 3n all over 6m to the third n. So m minus n is 0. Negative minus a negative is negative 6n over 6m to the third n. Now, this minus right here is not between anything. It just means negative 6. So this can be reduced because there's multiplication between every single one of these. So the n is n over n, that's a form of 1. The 6 over 6 is a form of 1. So I would have negative 1 over m to the third, and that's how you would simplify that one. So let's put all the pieces together here. I have two fractions with two different denominators. So the easiest way to get a common denominator is to multiply it all together. Now I'm going to write this twice just for simplification purposes. All right. So I have a 5 and a 4, that's 20. I have an x and I have a y to the third. That's my common denominator when I multiply them together. All right, so now I'm going to take this fraction right here first. The 12y is going to stay. The 5x is going to stay because they were there originally. All right, so now let's look at the denominator. The denominator here has a 5 but not a 4. So this is going to be times 4. This one has an x, but not a y to the third. And that's where that goes. If I take right now, if I reduce this fraction, if I've done this properly, it should reduce to 12y over 5x. All right? So that's the point of it. All right, so over here, I have a 4, but not a 5. So this is times 5. I have a y to the third, but not an x. Okay? So this is going to be all over 20 xy to the third, and I'm going to have 48 y to the fourth plus 25 x squared. Nothing cancels. There is a plus sign in between here. Nothing cancels because there are no factors that are common between 48 and 25 that would also cancel out with the factors of 20. They don't all have a y, they don't all have an x. So there's nothing that can be canceled. That's it. One final example. See if you can work this one ahead of me. In fact, these videos would be much better if, when I introduce a problem, you stop the video, work the problem, and then either watch me work it or jump to the end and see what the answer is. Because you'll get a lot more out of that than simply just copying down examples from the video. Okay, so the common denominator, they don't have anything in common, so the common denominator is going to be them multiplied together. And I'm going to go ahead and write them as one denominator. Okay, the 6 stays, the minus stays, and the 5 stays. I notice here it's missing a 4, and here is missing an x minus 1. Oh, I forgot the x. Sorry, that was in shadow. There we go. I think that's right now. Some of you are going, Miss Bonifield, you didn't do that right. Well, there you go. All right, so here's 24. Caught my mistake. minus 5x squared plus 5x all over 4x minus 1. And notice in the denominator, I just didn't bother to multiply it out. There's no advantage to doing that. Nothing will cancel. So I don't know if the top factors. I want to say it probably doesn't. But I would have 5x squared plus 5x plus 24, if I wrote it in the correct order, over 4 times x minus 1. And that's it. So, all right, come to class prepared probably to go to the boards and to do many, many of these examples. All right, see you then.